Okay, problem set 29. Second to last one of the semester. I do want to point out that I will be skipping one of the questions from the actual homework. Just because I don't think that I'm going to be able to explain that one at all. So I will be skipping it. I'm really, really sorry for anyone that needs help with that. I don't think that I'll be able to give you help with that question. But I do have examples for all the rest of them. So let's go ahead and take a look at number 1. So it says the foci of a hyperbola are plus or minus square root of 11, comma 0, and the asymptotes are y equals plus or minus 3 times the square root of 2 over 2x. Now, if we remember our our asymptotes for hyperbola are always going to be either plus or minus b over a times x, or they're going to be plus or minus a over b times x. And that depends on whether or not it's a horizontal or a vertical hyperbola. So in this case, it looks like our transverse axis, or a major axis in this case, is going to be our x-axis based on where those foci lie, because that's going to be like somewhere like that, which means that our hyperbola is going to look something like this. Which means that that's going to be an equation like this. And you'll notice that this is almost identical to the equation for an ellipse, which is why we want to be very careful here. The only difference between this and the equation for an ellipse is that this is subtracting. So it does matter which one of these comes first with a hyperbola because we are subtracting them. Whichever variable is that of our transverse axis is the one that comes first. So our transverse axis is the x-axis based on those foci. So it's going to be this minus this equals 1. Which means that our asymptotes are going to be based on that. So it's going to be y equals plus or minus b over a times x. And this is a little bit of an oversimplification because it's technically over a times x minus h, that is if it's not at 0. But it looks like our center probably is at 0 since our foci are the same distance away from each other, right? So we can presume, based on that, that our hyperbola is centered at origin. So it's just going to be x squared over a squared minus y squared over b squared equals 1. So that helps us narrow it down already. And now, because of this, I know that b over a must be equal to 3 squared to 2 over 2. Now, it doesn't tell me exactly what b or a is, right? I can't say that b is the top and a is the bottom because that might not necessarily be true. So instead, what we're going to do is we are going to turn one of these variables in terms of the other so that we can then plug that back into here to help us solve for it. So in this case, I'm just going to multiply both sides by a, so that cancels. So b equals 3 squared to 2 over 2a. Now, that means if I have b squared, that's going to be all of this squared, which is going to be, let's see, 9 times 2 over 4. So that's going to be, 9 times 2 over 4, that's going to be 9 over 2. So it's going to be 9 over 2 a squared. So now I'm going to take this and I'm going to plug it back into that original equation. Because now because that way we can have both of these radii in the same terms. Right, and then I can go from there and try to, or actually, hold on. Sorry, it's always a little bit of trial and error with the hyperbolas because they're not my strong suit. We also want to remember that when we're finding the foci of an ellipse, that's normally our foci squared equals the radius of the major axis squared minus the radius of the minor axis squared. With a hyperbola, instead of an ellipse, the hyperbola, it's just going to be our Pythagorean theorem rather than that minus. So I could also plug that in here. So I know that c squared is going to be 11. So 11 equals a squared plus b squared. B squared is the same as this, which means that 11 equals, well, this is one whole, so it's going to be 2 over 2, right? So it's going to be 11 halves times a squared equals 11. So now I'm going to multiply both sides by 2, or divide by 11 halves, rather. So 11 divided by 11 halves is going to be 2 times 11 divided by 11, and that equals a squared. So a squared equals 2, which then means that b squared equals 9 halves times 2, so it's just 9. So now we know a and b. That says b is 3, a is square root of 2. But all we needed was to find the equation of the hyperbola. So since we know a squared and b squared, I know it's going to be x squared over a squared, which is 2, minus y squared over b squared, which is 9, equals 1. And there's our equation. Okay. Number 2 is a similar question, except this time it doesn't look like it's going to be centered at 0. Or, sorry, it doesn't look like it's centered at origin. So it says the foci of a hyperbola are 0, 8 and 0, negative 10. So in this case, our foci are along our y-axis, so our trans, because that's going to be 8 and negative 10, and our center is going to be right in here, right? Because it's always going to be right between them, and our hyperbola is going to look something like this instead of the other one, which was horizontal, right? Which tells us that in this time, it's going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. And it looks like our center, since it's going to be right smack dab between those, our center is going to be at 0, what's right between those? Negative 2. So now, plug that in here, so it's going to be y minus 2 squared over a squared minus x minus 0, so just x squared over b squared equals 1, okay? And our asymptotes, let's see, I'm going to erase this part here. Our asymptotes, it says our y equals negative 8 over square root of 17 x plus 1, and, oh wait, my bad, and positive this plus 1. I made a small mistake. Right in between negative 10 and 8 vertically is not negative 2, but it is negative 1, and also we're subtracting, okay, so it's going to be plus 1. Sorry. This might be supposed to be minus. Yeah. Whoops, I definitely wrote that wrong in the paper by accident. But yeah, that should be minus 1, because our k value, because in this case, because it is a vertical hyperbola, it's going to be a over b times x minus h plus k. K in this case is a negative 1, because that is where it's centered at 0, negative 1. Okay, sorry about that. So now, it looks like a over b is something along the lines of 8 over square root of 17. Now we're going to do the same thing we did last time, right? So I'm going to multiply both sides by b and cancel that out. So now I get a equals 8 over square root of 17 b. Once again, we know our, do I know our foci? We know our foci Since our foci are 8 and -10, and our center is here at -1, our focus is actually, that C value is going to be this distance, which is the distance of 9. So C is going to be 9. So C squared is going to be 81. And we know C squared equals A squared plus B squared. So I know 81 equals A squared. Oh, actually, hold on. Let's square this now, actually, so that we can swap that out. So A squared is going to equal 64 over 17 B squared. So I'm going to plug that in for that A squared. So it's going to be 64/17 B squared plus B squared, which is, this is a 17/17. So let's combine that. Let's see, it's going to be 781. Oh, interesting. So 81 equals 81/17 B squared. So that's going to mean that if we multiply off that 17 to cancel there and divide both sides by 81, which cancels there, we get B squared equals 17, which means that A squared is then 64 over 17 times 17. So A squared just equals 64 because those 17s cancel. And now we can plug that in. So our equation is going to be y plus 1 squared over 64 minus x squared over 17 equals 1. And there's our equation for this one. I'll write that over here. Okay, let me erase some of that so we can have room for the next question. Oops. Okay, that's fine. This one is a little different because it doesn't tell us which conic section we're working with, so we have to figure that out ourselves. So it's given the equation x minus 3 squared equals y plus 5. We want to figure out what all of these are. Well, very first step is figure out which conic section it is. Well, I know if it was an ellipse, I would have both an x squared and I would have a y squared. So since I don't have those, it's not an ellipse. So it's not an ellipse. It can't be a hyperbola either, because a hyperbola would also have an x squared and a y squared. So it's not a hyperbola. It's also not a circle, because the same thing for circle. We'd have an x squared and a y squared. So it's not a circle. So then we've got parabolas. Would a parabola have an x squared and just a y? Yes, it would, because one of our forms of our parabolas is x minus h squared equals 4c times y minus k. So it is a parabola. So I'm just going to make a note of that so you don't forget. It is a parabola. In this case, our h is clearly a 3. So h equals 3. And then in order for this to work, right, we don't have any coefficient in front of that y, which tells me that this out here has to cancel out and turn into a 1 times whatever this is, which means that our c value must be 1/4, because 4 times 1/4 would be 1. And our k value must be -5 in order for that to be y plus 5. So now we know our h and our k, so that tells us that our, well, in this case, vertex, not our center, our vertex must be 3, -5, because it's h, k. So this only has a single vertex because it's a parabola, and it is that. Let's see, now we want to find our foci and our directrix is probably next as well. So if our axis of symmetry, well, okay, so this looks like it is a parabola that we're used to, so it's has symmetry with respect to the y-axis, so it's going to look something like this. So our vertex is, well, 3, negative 5. So our vertex is somewhere like that, and it's going to look something like that, I believe. Which means our focus is going to be somewhere up in here, and our directrix is going to be aligned somewhere down here. Remember that the focus and the directrix are equidistant from the vertex, or from any point on the line, technically. If we remember that our C value, that's typically the x-coordinate of our vertex minus the directrix. So if C equals 1/4, and we know the x-coordinate is 3, then our directrix must be whatever makes that true, right? So let's see. If I subtract 3 from both sides, I'm going to get negative 2 3/4 equals our negative directrix. So our directrix is 2 3/4. Oh, interesting. I might have gotten the direction of our parabolic curve backwards, because the directrix is typically on the, I guess, bottom, technically. So our directrix is 2 3/4. So say 2 3/4. This line right here is our directrix, which means that our focus, since this is our vertex, our focus has to be down here somewhere, that is where this distance is the same. Which means our parabola looks more like this, unless I made a mistake somewhere. But so our directrix is going to be y equals 2 3/4, or 2.75, however you want to think about that. Jumping to the axis, that's going to be the axis of symmetry in this case. So the axis of symmetry is, of course, the y-axis, but at this point, so at x equals 3 is our axis of symmetry. There's going to be no asymptotes, so all we have left to find is the focus. So in this case, it's not plural, it's just a singular focus. So how far away is 3, negative 5 from this point? Well, I could just subtract it. 2 3/4 minus negative 5. That distance is going to be 7 3/4. So this distance has to be the same, which means that I'm going to take negative 5, minus 7 3/4 to get a focus at 3, negative 12 3/4. There is our focus. It's probably an easier way to go about that, but that's that's how I can process it. I hope that all made sense. Let's take a look at number 4 next. This one's a little bit different from what we've been doing. So definitely take this one slowly. It says find 2 values of d such that the line negative 4x plus y equals d is tangent to the ellipse 2x squared plus 5y squared equals 50. And find the points of tangency. So what we need to do first is we're probably going to want to find the slope, of course, at any given point of this function. So what we're going to do is we're going to use implicit differentiation to figure out what that slope would be. The slope being dy dx, I believe. So I'm going to take the derivative, apply that power rule. Of course, and then I just manipulate that to isolate dy dx, so it's going to be 10y dy dx equals negative 4x. And then, of course, divide off that 10y, so I get dy dx equals negative 4x over 10y, or negative 2x over 5y, if I simplify that. So this is going to be the slope at any given point. That slope is going to be this. So in order for this equation to be tangent to this ellipse, the slope here is going to have to be the same as this slope, and then we have to find the points at which they touch, at which they're tangent. So I'm going to erase this bottom bit here just for space. Next, I'm going to put this equation into slope-intercept form so that it's clear what the slope is. So I'm going to add 4x to both sides. So you get 4x plus d. So the slope of this line is 4. So I'm going to set this equal to 4. And so, well, when is this equal to 4? Let's see. So that would be x over y. So if this is equal to 4, I'm then going to divide off that negative 2/5. So it's going to be 4 times negative 5/2, right, to cancel that out. So x over y is going to equal negative 20 over 2, or just negative 10. From there, of course, it's not perfect for us. From there, I'm going to turn it into, I think, a y equals. So I'm going to multiply both sides by y, so I'm going to get x equals negative 10y, or y equals x divided by negative 10. Okay, and now that must be true for this slope to equal this. And I also know that y equals this. So I'm going to set those equal to each other and solve for x. So I can figure out at what x value or x values they are. Yeah, sorry. Okay, so let's try multiplying everything by negative 10. So I'll get negative 40x minus 10d equals x. And then that's going to be negative 10d equals 41x. And give me a moment. I'm trying to think if I'm missing anything. I'm trying to figure out what that next step is. It's been a little bit since I've done this question. Okay. So I'm trying to figure out. Total brain fart right now. I'm sorry. Having a long day. Let's see. So I will just turn that into d equals this right now. Maybe. Or what did I do when I was doing this the first time? That's what the heck? Okay. Oh, it's entirely possible actually that I did not set that equal, but rather plug that into back into our ellipse. That's probably what I actually did. So, of course, if y equals 10, x over negative 10, y squared is going to be x squared over 100. And I can then plug that into here and then solve for x, because that's the only variable I'll have there. Over 100. Of course, that 5 cancels off and it turns into x squared over 20. Okay, let's find common denominator there so I can just put them together. So I'll multiply this by 20, so I'll get 40x squared plus x squared over 20 equals 50. So I'm going to get 41x squared over 20 equals 50. I'm going to multiply both sides by that 20. So, big numbers. 41x squared equals, will it be 101,000. So x squared equals 1,000 divided by 41. X is going to be plus or minus the square root of that. which I can actually, oh, blah. So that's going to be 10 times that. Sorry, I was just simplifying that radical because it is going to be the square root of this. Now, let's go backwards a little bit. Now I'm going to plug this in for a y value back in here to figure out, or sorry, I theoretically could plug that into this equation too as well, to figure out what y values are at this point, because this is going to be my points of tangency, which is going to be, so I'll plug that back up in there. So it's going to be y equals, I could be negative 10 over this over negative 10, and then y also equals positive 10 times this over negative 10, which gets us that y equals just this, and y equals negative this. So it's just 10 times smaller than that x value. Sorry if this is really hard to follow. But, so that gets us that, those x values of that, and our y values of this at those x values. So these are going to be our points of tangency. So now, in order to solve for that d value, those two d values, so first of all, our points of tangency are going to be, let's see, it was negative 10 times the square root of 10 41sts, comma, and that got us the positive one of that. So careful not to mix those up. So these are points of tangency. Just going to write those down. Okay, and then our d values we're going to solve for now. Using these, we're going to plug those in accordingly back into that equation. So if y equals 10 over 41, when x equals, sorry, square root of 10 over, when x equals this, plus d. Now we can just solve for d, because all of this is just numbers, as ugly as they are. So it's going to be square root of 10 over 41 equals negative 40 times square root of 10 over 41 plus d. So then if I add this to both sides, add that, this is going to be 41 square root of 10 over 41 equals d. So our first d value is that. And then we have to solve for a second d value. So we're going to plug in the other set of x and y values. So now it's going to be y equals negative square root of 10 over 41 when x equals positive 10 square root of 10 over 41 plus d. Now we just do the same thing. So this is going to be 40, and I'm going to subtract it from both sides. I'm going to get negative 41 square root of 10 over 41 equals d. So actually, going back up here, I could write that pretty simply as just plus or minus 41 square roots of 10 41s. And that's it. There's our answers. We got our points of tangency, and we got those d values. So there we go. I hope that was followable. Okay. Number 5 is an easier one. This one is just applying our understanding of parabolas. So it says, suppose a golf ball is hit so that it travels a distance of 300 feet along the ground and reaches an altitude of 600 feet. Find an equation for the path of the ball. Well, right here, we're going to start, our starting point, we'll call that origin. So it starts at 0, 0. It goes a distance of 300 feet. Actually, I'll write that over here so that's a little clearer. And it goes a height of 600 feet. Well, that tells me our vertex, well, that tells me it's a parabola with symmetry with respect to the y-axis. So it's going to be a parabola in the equation like this. Okay, we see our vertex is at this point right in the middle, which is going to be, well, it goes from 0 to 300 feet, so it's going to be right there. So our h is going to be 150 feet, and our vertex, our height, our k value is going to be at 600 feet, so it's going to be x minus 150 squared equals 4 times c times y minus 600. Now all we have to do to have our equation is figure out that c value. In this case, since we know both our vertex and a couple of other points, we know that end point and that start point, we can actually use those to help us solve for that c value. Because I know when I plug in 0 for my x value, my y value should also be 0. So I'm going to say that that's 0 minus 150 squared equals 4c times 0 minus 600. And then from here, it's going to be, oof, that's a big number. Well, I know 15 squared is 225, so it's going to be 225 with 2 zeros at the end, equals 4 times c times negative 600. So that's 22,500 equals, and I actually distribute that, so negative 2,400 c. And then divide both sides by that negative 2,400. I know I can cancel off those zeros, so now it's just 225 divided by negative 24, which I do not know off the top of my head. I know they're both divisible by 3 because this is just 15 squared. Oh, that's a good way I can think about it, actually. 15 times 15 over 3 times 8. That's going to turn into a 5. So now it's 75 over 8. And I actually don't think I can reduce that any further. Yeah, because this doesn't share any factors. So our c value is going to be 75 eighths. Or, sorry, negative 75 eighths. I lost my negative. Don't do that. Which means now if I plug that back into this equation, our equation for the path of the ball is x minus 150 squared equals 4 times this, which I will actually cancel out, so it's going to be negative 75 halves. So negative 75 halves y minus 600. Boom. Then I believe the rest of the questions for this homework are just integrals. So it's just integration. This first one is using that fundamental theorem of calculus. So if f of x equals this function, or this integral in particular, then the derivative of f of x is what? Well, remember that using that fundamental theorem of calculus, it's going to be, or I guess I could rewrite that. So the derivative of an integral with bounds like this is going to be like so. I'm honestly surprised that I know that off the top of my head. But so that's going to be that. So in this case, we're taking the derivative of this. So it's going to be the derivative of that top one. So it's 4x cubed. Or I suppose I could actually write it over here. So 4x cubed times the function with this plugged in. So it's going to be times 2 plus x to the 12th all to the 1/5 minus now the derivative of the second one times the function with that plugged in. So 2 plus x to the 9th all to the 1/5, and boom. That's all that is. That's just a matter of remembering this. The next one is an integral where we'll have to use some u substitution, I believe. And this might take some trial and error. So bear with me a little bit. So let's see what happens if I make u equal to the square root of x. which is the same thing as x to the 1/2. My du value is going to be 1 over 2 square root of 2, just because I know that that is the derivative there. Feel free to do that derivative out if you're not sure, but I happen to know this off the top of my head. And this actually is really, really close to that. Oh, so that helps us a lot, except for the fact that this is squared. Oh no! So let's backtrack a little bit, actually. We probably could do that. The reason we can't do that u substitution is because then we'd have the du inside of the squared, and it wouldn't actually be replacing that dx. So we have to square this first, which is not a pretty one to square, but that's okay, because we can still do it. It just won't be pretty, and that's okay. So distribute that, so it's going to be x plus square root of x over this, plus another one, so I'll put a 2 in front, plus this times this, which is then going to be that. And that, of course, cancels, so that's going to be over 4. And actually, those cancel too, so that's actually just 1/4. Okay, that's not as ugly as I thought. And I'm actually going to backtrack to what I just did there, because I know I just went through that a little fast. So I got this because I'd had this. Of course, this cancels out, and I'm left with 2/8, which reduces to 1/4. Boom. Okay. Now from here, I actually shouldn't need to use u substitution. I was mistaken. So now I'm just going to rewrite my integral as what we just got. And now we just integrate. We undo those power rules, and this one is 1 over 64 times 1 over x, if that's helpful. And remember that the integral of 1 over x is natural log of x. So this would be 1 over 64 times natural log of x when we integrate that. But let's write all that out. So this is going to be 1/2 x squared plus 1/4 x plus natural log of x over natural log of x over 64. You generally want to put the x in absolute value inside that natural log, since natural logs can't have values plugged into them that are 0 or lower, right? But since the values that we're going to be plugging in are positive, then it's okay to put the parentheses there. But you want to be careful of that. And now you just have to plug everything in. So that's going to be 1/2 times 16, which is 8. 1/4 times 4, which is 1, plus natural log of 4 over 64. And now we subtract everything with the 1 plugged in. So it's going to be 1/2, 1/4, natural log of 1 over 64. So that gets to be 9 plus natural log of 4 over 64 minus, and that's going to be 3/4 minus natural log of 1 over 64. It's worth noting, when we look at natural log of 1, right, that if I have natural log of 1 over 64, remember that that is also 1 over 64 times natural log of 1, which I could then, with our log rules, rewrite as natural log of 1 to the 1/64th. In doing that, I know that 1 to the power of anything is just itself, right? Because no matter how many times I multiply it, it's always going to be 1. So that's just going to turn back into natural log of 1. So natural log of 1 over 64 is the same thing as natural log of 1. Continuing, let's do that 9 minus 3/4. That's going to be 8 1/4. Now, I am going to use my log rules just so that I don't get confused there. So remember, this is 1 over 64 times this, or I could write it like this, just to be clear. And we're subtracting a natural log of 1, which means I'm dividing this interior by 1, which changes nothing, and actually just means that that can go away. So this 8 1/4 plus, and I'm going to rewrite that as I had it before. This is probably the most simplified we can write that. And that is our answer. I believe you can put it into the into the homework that way, but feel free to put that into a calculator and put in a numeric answer instead. Okay, now I am going to erase this just because we have another integral right next to it. Actually, I will rewrite that right there really quick. Okay. Now, let's take a look at this next integral. It's another definite integral, but this one is an absolute value. So it is from 4 to 0, absolute value of 2x minus 4 dx. And what I notice about this first is not just that it's an absolute value function inside, but also that it is an improper integral. And of course what that means is just that my bounds are flipped, and that might make it a little bit more confusing for us. So I'm going to flip it back. I'm going to do 0 to 4, and remember, because of our properties of integrals, in order for this to be equal to those flipped bounds, I have to multiply it all by a negative. Now I'm going to, because this is an absolute value, I'm going to figure out where that center is, and I'm going to split this into 2 separate integrals. So looks like that center is going to be at 2, right? Because 2x minus 4 equals 0 at x equals 2. So I'm going to have an integral from 0 to 2 of something, and then an integral from 2 to 4. And remember, we do have to multiply by that negative. We can distribute it to the inside if we like. I'm just writing them outside right now to make it a little easier on myself. So first, I need to figure out which way it's going. I assume it's going to be something like this, which means that, so if this is x equals 2, and then maybe this is x equals 1, x equals 0, right? Of course, plugging in this side, I'm going to get a negative inside of there, so I need to multiply it all by a negative anyway, so it's going to be negative 2x minus 4, and funnily enough, these negatives cancel out. So I can just write that, I can get rid of both of those and just have it be the integral of 2x minus 4 dx. And then over here, this one, that's going to be all of this space, which is going to be just a positive. But I have this negative on the outside, remember? So I'm going to go ahead and distribute that just for my own sake. So that's going to cancel out there. And now these are the integrals I have to take. So now it is pretty straightforward. I'd hope that by this point in this semester we're capable of doing this on our own, but I will walk through it nonetheless, just to make sure we don't make any mistakes. So I'm going to do this first one, undo that power rule, so it's going to be 1/2 x squared times that 2, so it's just x squared, and then minus 4x from 0 to 2, and then plus, it's going to be negative x squared plus 4x from 2 to 4. Continuing, plugging that 2, that's going to get me sorry, zoned out for a second. Plugging in that 2, it's going to get me 4 minus 8, which is of course a negative 4 for that first part, and then subtracting the 0 means nothing, so I'm not going to write it. Then we want to add this over here, which is, let's see, so it's going to be negative 16 plus 16, and then minus negative 4 plus 8. So this is going to equal negative 4. Those cancel out, plus, well, this is going to be a 4, and we're subtracting it, so it's plus another negative 4. So our answer is going to be negative 8. And I know in the past we've said that we can't have negative area, right? We technically can, but we don't like to. In this case, we do need to have it negative because it is this improper integral. Writing positive 8 would technically be incorrect. Unless I made a mistake somewhere. Okay. Oh no, I accidentally opened Photoshop and that might pop up in a second. Okay. Sorry about that. Okay, so now for number 9, this is an indefinite integral, but we will need to use some u substitution for this, right? So we have the integral of x times 12 minus x to the 3/2 power. So probably the easiest thing to do here is just to make this interior our u and manipulate that further if we need to. So taking the derivative of this, that's going to be just -1. And then, of course, we'll still have this x outside, so I'm just going to manipulate this to get x by itself. So if I subtract 12 from both sides, I'll get u minus 12 equals -x. And then divide both sides by negative, so it'll be -u plus 12 equals x. Or actually, nope, I don't have to do that, because I can then multiply that, and I'll get u minus 12 times du is going to be -x times -1, which is just x. So there, makes it nice and simple. So now it's going to be u minus 12, of course, times that du, but I'm going to write it at the end, times then my u times u to the 3/2 du. Now, this still looks like we can't do it, but all we have to do is distribute. So it's going to be the same as u to the 5/2 minus 12u to the 3/2 du. And now we just integrate and then plug back in our u value. So it's going to be 2/7 u to the 7/2 minus, so it's going to be u to the 5/2, so it's going to be 24/5. Of course, plus c, so don't forget that. And now our official answer is going to be that, but I'm just going to plug back in that value. So it's going to be 2/7 times 12 minus x to the 7/2 minus 24/5 times 12 minus x to the 5/2 plus c. That's all there is to that one. And then we've got just one question left. This one is a more time-consuming one, though. So it says f of x equals 2 over x, and g of x equals 2 over x squared, and we want to find the area between them on this interval. So I'm first going to check for any intersection points on this interval, just to make sure that we get all positive areas, and split up any integrals if we need to. So I'm going to set them equal to each other. And of course, I can multiply both sides by that x squared. And that cancels, and then one of those x's cancel. So I get 2x equals 2. So x equals 1. So they intersect at x equals 1, which is on that interval, sorry. So I know it's going to be one integral from 1/2 to 1 of something plus then the rest of the way. Now we just need to figure out which function is on top for each of those integrals and then do them. So in between 1/2 and 1, I'll plug in maybe 3/4. So f of 3/4 is 2 over 3/4, which is 8/3, or 2 1/3 if that's easier to understand. And then if I plug in 3/4 for g, that's going to be 2 over 9/16, which is then 32 over 9, which is 3 and something, which means that for this integral, g of x is on top. So it's going to be from 1/2 to 1, it's going to be g of x minus f of x. And then presumably if they're going to flip, Of course, you always want to double check that, but I know in this case that they will, but you would just do the same thing. Just pick a value on here, plug it into both, and see which one's larger. Okay. Now, so it's going to be 1/2 to 1 of 2 over x squared minus 2 over x dx plus 1 to 5 of 2 over x minus 2 over x squared dx. Of course, for this part, it's just power rule. So it's going to be taking the integral. So that's the same thing as 2 times x to the negative 2. So I'm going to add 1 to the power. So it's going to turn into a 2 times x to the negative 1. And of course, we divide by that. So that becomes a negative 2 times x to the negative 1, or negative 2 over x. This is, of course, that natural log again. So it's going to be minus 2 natural log of x, all from 1/2 to 1. Now we do the next one, which, again, it's those same things, just flipped signs, right? So it's going to be 2 natural log of x, and that's going to be negative 2 over x, but we're subtracting it, so it turns into a plus, and that's from 1 to 5. Now I plug in those values. So plug in the 1, so it's going to be negative 2 over 1, which is negative 2, minus 2 natural log of 1, and then, of course, subtract the bottom, so it's going to be minus a negative 2 over 1/2, so it's going to be plus 4, because 2 over 1/2 is 4, because it's 2 times 2. And then, again, minus a negative, so it's plus 2 natural log of 1/2. And that's all for this part. Now I'm going to also add this down here, so it's going to be 2 natural log of 5 plus 2 over 5 minus 2 natural log of 1 minus 2 over 1, which is just 2. Now we'll begin combining like terms. So of course, negative 2 plus 4 is 2, and then minus 2 is 0. So those disappear. So now I've just got 2/5 is our only other non-log term. So it's going to be 2/5. And now I've got all of this. That's minus 2 natural log of 1 plus 2 natural log of 1/2. Oops, I did not mean to go that far. Plus 2 natural log of 5 minus 2 natural log of 1. And, okay. Now from here, right here, I see, again, that this is just going to be, this is going to disappear, right? Because that's essentially natural log of 5 squared divided by 1 squared, right? If I use my log rules, this becomes this, which just stays as natural log of 5 squared, or 2 natural log of 5. So this disappears. So I'm going to erase it. And now we've just got those other pieces left. Now I get a little confused when I have the negative in front, because I know that minus is division, but I suppose we'll just consider this. This is addition right here, so it's multiplication. So that's natural log of 1 squared times 1/2 squared, which is just natural log of 1/2 squared. So again, this disappears, but that negative doesn't, because we left that out in front. So this is minus all of this. And now I can combine those, and I can leave that 2 out front. So that's going to be 2 natural log of 1/2 divided by 5, which is 2 natural log of 1/10. So then all of that simplifies, and so it's going to be 2/5 minus 2 natural logs of 1/10. And of course, the reason I could leave that 2 in front, we can always double check it. Remember, because it would be 2 natural log of 1/2 squared divided by 5 squared if I had put them back in first. If I do that now, that's just the whole thing squared, which distributes to be this. So we could leave it like that. I'm not going to plug that into a calculator, and I'm just going to leave it like this. I believe you can type it to the homework like that. So our answer is 2/5 minus 2 natural log of 1/10. That's it. All right, that is all that there is for this homework. This one was tough to explain. So I hope that my explanations made sense, and I hope that this video was helpful. Thank you for watching.